Hello teacher, and welcome to our presentation for Lab 3 assignment in the course Computer Applications for Industrial Engineering. Our group member has 5 members. And here's a quick look at what we cover in this video. There are 5 parts for our presentation. For the first part, the introduction. The capital vehicle routing problem, we can say that CVRP is a type of VRP in which a vehicle with the limited capacity need to pick up for delivery goods at various locations. Each item has information about its quantity, such as weight or volume, and the vehicles have a maximum capacity they can carry. The objective is to pick up or deliver the item at the lowest cost while ensuring the vehicle's capacity is never exceeded. The problem is determine the routing information for vehicles, such as the total travel distance is minimized and the total load carried by any vehicle never exceeds its capacity. Go to the second chapter, we will show the problem with the multiple types and capacity of goods. In the first, for more complex case, we can see that the problem can involve different types of goods with specific capacity for the constraint for each type. For example, a fuel delivery truck might carry multiple fuel types in separate tanks of varying capacities. Handling such as synchronous requires specialized callback function and distinct capacity attributes for each type of good. For each location on the route, the result should display two bars, the index of location and the total load carried by the vehicle upon departure from the location. We can see the route at the picture below have including two bars, the location and the load carried. And now we move to the chapter 3, the key component of the code. The first is the component of the objective function. The objective is minimize the total travel distance of all routes. The formula like that where Cij is distance between the node 1 and j is the Sij is binary variable indicating whether the edge between I and j. And the second, for the decision variables, the routing variable indicates whether a route goes from the node I to the node j for a specific vehicle. Load variable is a check the cumulative demand specified by the vehicle on each route. We can say that like Sij equal 1 on Sij equal 0 otherwise. And finally, for the constraint, part 1 is demand the satisfied function. Each customer demand must fulfill exactly once by one vehicle. Second, capacity limit. Each vehicle can carry goods up to its capacity. Third, depot constraint. All routes must start at the end of the depot, like the vehicle leave and return to the depot exactly one time. And final, subtotal elimination to prevent the creation of the strong cycle that do not include the depot. Now we move to chapter 4, and I will explain the code. First, let's say we start with the install autotunes. The purpose that they install the autotunes library, which provides a tool for solving combination array optimization problems and includes CVRP. Next, we create a data model function. And now we create a model and manage indices. First, routing index manager. That's mean manage the mapping between the internal indices used in the model and the actual node index from the data. And secondly, routing model creates a routing model and defines constraint and costs. Next is the distance callback function. With the proposed distance callback is for the meaning returns the distance between two nodes based on the distance matches. And the next is set a cost elevator of all vehicles. As for assign the distance as the cost for each act like connection in the model. And now we come to the capacity constraint. The first is demand callback. It means to return the demand at a given node, and the additional with vehicle capacity. That's it for as constraint to ensure the total goods on each route do not exceed the vehicle capacity. And that's it. Now in the solution strategy part, the purpose of it is first demand callback is to return the demand at a given node, and the second is additional with the vehicle capacity is to add constraints to ensure the total goods on each route do not exceed the vehicle's capacity. And now we print the result. The purpose for the objective is display the objective value. This means the total distance of all routes. Secondly, dig route that records the nodes visited by each vehicle. The third is total distance, the total distance of all routes. And the final is the total load. The total load is the total goods transported. And finally, that's it, the man function. The purpose of it is execute the entire process, prepare the data, create a model, add constraint, final result, and print the result. And finally, is the result. After solving the problem, we might get a result like this. Objective value is equal to 6,208. The total distance in meter for the example road, like the vehicle 0 is from the depot and transport to the location 4, to the location 3, 1, to location 7, and now back to the depot. Another one is the vehicle 1, like from the depot to location 14, 16, 10, 9, and back to the depot, and etc. And the same for vehicle 2 and 3. Each route respects the capacity constraint while minimizing the travel distance. And in summary, CVRP helps us to optimize the logistic operation by solving complex routing problems with capacity limit. Using a tool like our tool, we can model and solve real-world problems efficiently, saving cost and time. Thank you for listening, and I'm happy to answer any question under the comment. Thank you for your attention.